You multiply. Yeah, or you can multiply by 2 first, both sides, so it'll be easier. Mm. All right, and now you can find y. 6 over 5 plus 5, 11, no, 31, no, 25, 25 plus 6, 20, okay, 31 over 5. This is your y, right? Because that is y equals 2x. No, where did you get 5? I wonder where you... Yeah, that's why, that's why I was like, where did he get the 5? That's why I was confused. Like, why is he talking about 31? Oh, okay, you're done with this. This is for x. You're done with that, okay? So you already found x, which is 3/5. Yes. So you're plugging in the value of x here to the equation y equals 2x plus 1. So to find the value of y. So it should be 1. So it should be 11 over 5. That's why I was confused. Why is it 31? So you should change this. Change this. It should be like this. Y. Yeah. Like I was, oh, where did he get 5? So what is y? Yes. So y is 11 over 5. Therefore, the point that is closest to 0.12 on line 2x plus 1 is 3/5, 11 over 5. Can you please clear the board? I cannot clear this because you are the host. Okay, that one is the next problem. Okay. Find the distance from 0.56 to the line 6x 6x minus 4y equals 0. So this is similar. So we're given here the point of 5, 6, and then equation of the line 6x minus 4y. But it's we don't solve this the same way like we did a while ago. Yeah, because this is from a point to the line. Yes. So we use the distance formula. Oh, our standard equation what's this? Ax plus by plus c equals 0. So the distance is, do you know the distance? Will be the coefficient, okay, ax sub 1 plus by sub 1 plus c over the square root of the sum of the square of a and b. That is 6x minus 4y minus 0. It was 0, or just simply 0. Okay, why did I have to? Okay, now we already know the coefficients, and we know the 0.56. Then we substitute the values into the distance formula. So we substitute that. What would it be? Okay, you can do that. Absolute value. Don't forget the absolute value. All right. All right. The 0, just 0. Okay. Then divided by okay. Yes, simplify. So 6 times 5 is 30. Yes. 36 plus 16 square root of 52. Yes, but you can reduce or further simplify square root of 52. 52 can be written as 4 times 13. Yeah? Yeah, you can write it. 6 over square root of 52 is 4 times 13. So you can simplify it further. And 4 is a perfect square, so square root of 4 is 2. So this would just be 6 over 2 square root of 13. Got it? Yeah, that one is correct. But you can further simplify that. I'm sure your teacher would ask the simplified form. And then 6 is divisible by 2. This is 3 over square root of 13. And then you cannot leave a radical in the denominator, so you have to rationalize. You multiply both the numerator and denominator by square root of 13. Then this would become, okay, I will write here, maybe I should just delete this. Okay, so we have 6 over 2 square root of 13. Can you see this? And then this would be simplified to 3 square root of 13. But we cannot leave the radical in the denominator, so we rationalize. We multiply both the numerator, both the numerator and denominator by the denominator. Then this would become 3 square root of 13 over 13. So this is the final answer. Therefore, the distance from point 5, 6 to the line 6x minus 4y equals 0 is 3 square root of 13 over 13 units. That's yes. This one. Find the distance from the point Q 0, 1, 4 to the plane 3x. Yeah, because we have 3 variables here, x, y, and z. So we use the distance formula. Yeah, so you write this in, you should equate this to 0. So you transpose 5 to the left. This would become 3x plus 4y plus 3z minus 5 equals 0. And then the distance formula. Yeah, but your distance formula, it will extend. It would look like this. The absolute value of a, x sub 1, plus b, y sub 1, plus c, z sub 1, plus d, that is your 5. And then square root of a squared plus b squared plus c squared. That one. No, because that is the constant. So we will only use the coefficients of x, y, z, because we're only given x, y, z here. The same with the xy plane. So we identify the components of the plane. So A is 3, B is 4, C is 3, and D is -5. Okay. Then x sub 1, this one. X. This is x sub 1, y sub 1, z sub 1. Should be absolute value. -5. Mm-hmm. Mm-hmm. Okay. 11 over square root of 34. Or you can rationalize this. 34. And you have 11 square root of 34 over 34. You cannot further simplify 34, right? Yeah. So that would be the answer. Is this one? Alright, so here, this is different. Find the linear equation of the plane through the point with the normal vector 1, 5, 6. So we need to find the linear equation of a plane. We're given the point. So let's identify the given first. So given here, a point on the plane. So let's say this is x sub 0, y sub 0, z sub 0. And the normal vector, this one, normal vector. So let's just denote that as normal vector. A, B, C. This is 1, 5, 6. So we can use point normal form of the plane equation and convert this to linear equation form. You know the point normal form of the equation? Point normal form. Because we're given a point and a normal vector form of, yeah, plane equation. So that would be A times x minus x sub 0 plus b times y minus y sub 0. Maybe you're familiar with this formula. Oh, what do you have there? What formula do you have there? Yeah. And then we substitute the values. So we substitute A. A is, what is A? Okay, so it'd be 1 times x minus x sub 0 No, we don't know, because we are asked for the linear equation. Yes. So you substitute that. Mm-hmm. 5. Mm-hmm. 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 All right. Then you combine like terms. So that would be the equation. That would be the linear equation of the plane. Yeah. Can you check if it's correct? Yeah, it should be that, like that. It's just sometimes it's complicated in the book. It depends on the book that you're using, because sometimes authors, they make it very complicated and you won't understand it. It's correct? Yay! Okay. All right. Okay. Can you clear the board? Why? How did they teach you? That one is the magnitude. That one is different. Because this one is for when you're looking for a line that is parallel to yeah, you can send me all of the books and we will study all about it, because it's like this. Like, say for example, you're given like a vector u and another vector v, like that, and we look for vectors that are perpendicular or line perpendicular to v and u. So let's say this is this is u and this is v, which is parallel to, let's say, w1, and this is w2. I think that one is what you are talking about here. That one is projection of u onto v. So w1 here, yeah. So if you look for a line parallel to, what's this, parallel to v, so w1 here is parallel, the component of w sub 1 is equal to the projection of u onto v, and the formula is like this. So that would be the dot product of u times v, then the square of the magnitude of v times u, times v. Yeah, so that is for the parallel. If you're looking for line parallel to v, let's say w sub 1 is parallel to v. But if you're looking for the orthogonal or perpendicular line, this one, which we denoted as w sub 2, perpendicular to v, then the formula would be different. This is the formula of the parallel. The perpendicular formula is this one, u minus w sub 1. So you need to solve for w sub 1 first. And w sub 1 is equal to this one. Okay. The dot product, you should know the dot product first. You know the dot product? So dot product of u and v divided by the square of the magnitude of v. That one is matrix. That one is different. Dot product is simply dot product. Dot product is, let's say we're given a 3, 5, and the u is 3, 5. V is equal to, let me use another color. Let's say u is 3, 5, and the component of v is 2, 4. Okay, so the dot product of this u dot b is just the product of the x plus the product of the x values, which is 3 and 2, plus the product of the y values, which is 5 and 4. That one. So that is the dot product. Yeah. And for the magnitude, is the same as like we did square root. That will be all over, because this is all over the square of the magnitude of v. Yeah, so this would become square root of the square root of 2 squared plus 4 squared, and then times vector v, which is 2, 4, that one. So that's how to solve for projection of u onto v. Yeah, so that's how to do it. And then for the orthogonal, you use this one, that formula. You already have the w sub 1, then you subtract it from u. You already have u. U is 3, 5. Orthogonal. All right. So, okay, let's solve the other problem, the last one. Can you please clear the board? The other one is a complicated. So let y equals this one, matrix, and u. Compute the distance d from y to the line through u and the origin. This is projection. Yeah, because we are asked to compute the distance d from point y to the line passing through vector u and the origin. So we use that one. Projection meaning parallel. Yeah, the one I just showed you. So projection of, what's this, y. We get projection of y first onto u. So that is the dot product of y. I should expand that. Can you see me writing here on this side? Projection. Okay, projection of y onto v. Y onto u. U. So that is just the dot product of y and u over the square of the magnitude of u times u. Yeah? Okay. So the distance from y to the line through u and the origin is just the magnitude of the vector y. No, this one is for the distance. Oh no, where is the problem? It's gone. How come it's gone here on my side, on my end? This one, that one. So the distance from y to the line through u, that is projection, this one. That is parallel. But the distance from y to the origin, that is orthogonal. So the formula for that is y minus this one. Y minus the projection of y onto u. So this one is supposedly our w sub 1. So our w sub 2 is that one. But from the one I showed you, that one is w sub 1. And now we can calculate. Okay, now we can calculate the projection of y onto u. Okay. Yes. That is dot product. So we multiply. How come it keeps on? Okay. Okay. No. I can see you writing now. So y dot u, you have to indicate that so you won't be confused. The dot product y dot u is equal to 3 times 1, okay, 3 times 1 plus, okay, minus 54 plus 15 is that 15? Okay, plus 15 here because you only wrote 5. So y dot u is equal to what is that? It's negative 36. This is 54, right? 3 minus 54 plus 15. So that is negative 54 plus 18, which is negative 36. And now we find the square of the magnitude of u. What is that? From the formula, that one is, yes, the square root of, the square of the square root of 1 squared, okay, 1 plus 36 plus 9. Okay, so that is 46. And now you can plug in that one to w sub 1. So projection of y onto u is equal to negative 36 over what's that, 46 times u, 1 6 negative 3. What is that? You can reduce negative 36 over 46. You can further reduce that. 36 divided by 2. Yeah, by 2, I think. So this would become 18. Yes. And then you multiply by vector u. So what are you studying? Why do you have this? Are you studying engineering or machine learning? Ah, I see, that's why. Okay, so that is, let me just, maybe here. So projection of y onto u is negative 18 over 36 at 23. Then the other one, 18 times 6, that is 108. 108 23. And the other one, then the other one is negative times positive over 23. Okay, so we already have w sub 1, the projection of y onto u. And now we need to calculate the distance from y to the origin. Yeah, minus, yes. So that would be y minus w sub 1. What is y here? Y is 3, negative 9, negative 5, minus that one, negative 18, 23, negative 108, 23, 54, 23. $87, okay, yeah, 87, yeah, 23, and the other one, negative 9 plus 108. Positive? Is it positive? Yeah, positive. 9, 23. Then, yeah, sometimes we forget the basic. So negative 5 plus 54. Okay, negative 7 over 23. How come I'm not? Negative 7? No, negative 47. No. Oh, no. Oh, this is whole number and fraction. It should be like this. And then I'm following you. It should be 3 minus plus 18 over 23. So that would be 80. Yeah, you got that right. And then the other one is negative 9 plus 108 over 23, which is negative 99. And then the other one is negative 5 plus 54 over 23. So that is negative 169. Oh, no. No. Okay. 23 times 5. And negative 115 plus 54. It's not minus 54. Oh, it's minus 54. This one. Because 54 is positive. So it should be negative 115 minus 54 is negative 169 over 23. So now we already have everything. But we are asked for the distance. The distance D. Yeah, this one is only the first one, projection of y to u. That one is the distance from u to vector u, y to vector u. And this one is the distance from y to the origin. Yeah, but we are asked to compute the distance d. Yeah, compute the distance d. So we subtract y minus, we get the distance for that. Y, okay. Can I delete this? Yeah, be sure you remember all of those. 87, negative 99, negative 169. Okay. So the distance would be, okay, the square of those, everything. Okay, the square of, what's that? 87 over 23. Negative 99 over 23 plus, what's that? Negative 169 over 23. So that should be the distance. Distance is the magnitude of the distance from y to the origin. So the distance d is the magnitude of the distance from y to the origin. And this is the formula. Yes. Okay. So this is 87. They have the same denominators, right? So you can just do 23 squared minus 99 squared. No, plus negative 99 plus negative 169 squared. So distance is, what is that? 87 squared is 7 times 87. That is 7,569. Then negative 99 times 9 times 981. 9,801. Then negative 169 times, this is 28,000. Can you check in your calculator? 23. 5, 2, 3 times 3, 9. 69. Then 3 times 2, 6. It is 529. No. No, I'm computing like, yeah, in my head, but I'm computing like, like, that's why I want you to check, because I'm not a calculator. 87 times 80. Sometimes my brain works, sometimes it's slow when I'm thinking of like uh, too much, because I have a lot of things like going on doing my research. So you do software engineering. That's nice. Okay, so what is the answer? Okay, 45,931 over 520. We can reduce this. Can we divide 45931 over 529? 529. So 45,931 divided by 529 be something like 8. It does not. Okay, you get the square root of that. So if you divide that, it will be 80 plus, right? So you get the square root of that one. What will be the... Yes. 8. Okay, so that would be the distance 9.318. So the distance D from Y to the line through U and the origin is approximately 9.318. Yes. So you get the